Hi, I'm Hubert Delay from StarTree, and this presentation is about the streaming plane, the plane that bridges operational plane and the analytical planes together. This is a quick blurb about me. I'm Hubert Delay. I work for StarTree as a developer advocate, and I've written a couple of books. So if there's something you're interested in, specifically streaming data mesh was released earlier this year. In this session, you'll be learning these lists here, the data divide, what streaming is and how it relates to the streaming plane, and how the streaming plane works and why it works well. So let's start with the data divide. If you're familiar with a data mesh or heard of the term data mesh, you'll know that Zhamak Dehghani, who is the creator of the data mesh concept, came up of a term called the data divide, which is the division of the operational plane and analytical plane. These are data planes that contain data from the operational side and the analytical side. What happens is that data moves from the operational plane to the analytical plane for analysis, because you can't do that kind of workload in the operational plane. Let's take a look. This is a diagram that kind of outlines the data divide. On the left is the operational plane, where you find your traditional OLTP databases that back your user-facing applications. In it, you're going to get inserts and updates and deletes of your data, but all that information actually flows out of that plane and into the analytical plane, where we could do further analyses on it and get insights of behavior of the application or the users that are using it, and so on. The path from left to right is a downstream path, meaning there are lots of tools that enable this to work well. In fact, connectors live in here, streaming platforms live in here. Lots of tools enable this. So it's a really easy path. That's why they call it a downstream path. Actually, the path going back is an upstream path. Getting data out of the analytical plane is actually a very hard thing to do. What happens on that downstream path? There are a few things. There's probably more than this if you are using an elaborate ETL process. But you have your cleansing, you typically enrich your data as well. You obfuscate it or secure it in some capacity, so that by the time it gets to the analytical plane, users of that data feel confident that it's trustworthy and secured and in a format that they could do proper analytics against it. A more detailed look at the same data divide is that on the right-hand side in your analytical plane, you have these specific servers or systems that cater to analytical questions like column or databases. If you want to get that data out of the analytical plane, you have to use a tool that promotes reverse ETL. It's ETL going from left to right, reverse ETL from right to left. And there are specific products that enable you to do that, because it is hard to get data out of the data warehouse or the analytical plane, typically because you have systems that don't want to relinquish that data. They are data that are compressed or in column or format, or in some other way that can't be forwarded back to the operational plane. And on the operational plane, you have your row-based OLTP databases that provide you with more with the transactional workloads that go along with the application. So what is the streaming plane? In essence, it's these components in here. There are connectors, streaming databases. There's real-time OLAP databases, streaming platforms, and stream processors. They all work on the stream because the two planes, the operational plane and the analytical plane, are planes that hold data at rest. data is sitting at rest, not moving. To get them to move to the other planes, you need a plane that moves that data, which is what the streaming plane is. Here's a more elaborate view of what the streaming plane is. There are three major components inside of it. There's the queues, or the topics, like in Kafka, that hold the streams, that move data, that capture the data and move it towards the other side, or the analytical plane. You have a way to serve data from the streaming plane, and you have a way to process that data in the streaming plane. Processing is your transformation, like your enrichment and your cleansing. The streams hold your real-time data, and the serving serves your data to the other parts of the business, either back to the operational plane or to the analytical plane. In this case, if you look at serving, in the bottom here, you'll see there are three possible components inside. There are real-time OLAP databases like Apache Pinot. There are streaming databases and another streaming platform. In this case, we have an icon for Apache Kafka. In the processing box at the top, you have Apache Flink and yet another streaming databases. These streaming databases can be the same instance or different instances. Likewise, the Kafka icon here, they can be the same instance of Kafka or different instances of Kafka where they replicate that data across. If we delve into how the serving box of the streaming plane works, it's basically using materialized views and push and pull queries. What happens is that when you create a table, or like a real-time table in the streaming plane, there are two types of queries that are going up against it. One that is pushing the data into a table, which is what we call a materialized view. And there's another query that's getting that data out and presenting it to a user or an application. And this diagram here we see on the right that is populating a dashboard or a real-time dashboard. The materialized view is being also populated using a push query. There's a balance between your push and pull queries. The more logic you put in your push query, the less you can do in your pull query. Conversely, if your push query is not doing too much, then you could do a lot more with your pull query. But with flexibility, your pull query, the more latency that you'll incur because you're doing a lot more. The pull query is typically a synchronous request response API, while the push query is an asynchronous push query or updating of the materialized view. So there is a balance you have to make depending on what your use case will be. A bit more on that streaming layer, or the streaming serving layer, is are these concepts. There are synchronous data products, and in this case, where these tables can be data products. There are synchronous ways of consuming that data, and there are asynchronous ways of consuming that data. Anything synchronous can be presented as a row-based or a columnar-based table or data store. That data store can be populated in an application and so on. What's unique about the streaming plane is that it can also present asynchronous endpoints or APIs to your data. What that means is that you're consuming data out of, say, a Kafka topic, but you now are responsible for creating that replica or that view of that data. You have to implement the upsert of that data and present that in your application. So in the replica up at the top right-hand corner, that replica is your responsibility because the API ends at the asynchronous level. So why does this work well? Basically, the replication capabilities really allow you to distribute real-time data across the globe easily. By having multiple Kafkas in there and building different materialized views, you can have many different views of your data across the globe. What this allows is that in every continent or every region of your data is being consumed locally. Imagine a cloud of tables inside your streaming plane that allows you to really basically consume data from anywhere in the globe, but it's that's always in streaming in real time, right? But you're consuming this data locally, not remotely from a remote database. But this is a summary of the what's inside the streaming plane. Basically, what it gives you is these are the requirements that you would need to be able to build a streaming plane and present data products to users. If you have any more questions, if any questions, please contact me here, and good luck.